Okay, so part two, using biological and habitat indices together for bioassessment of California streams. In the overview, I described how BMIs are powerful indicators of stream health because of their integrated response to multiple stressors over time. However, other assemblages, like fish or algae, often respond differently to various stressors and over different time scales. One of the long-term goals of the Swamp Bioassessment Program has been to develop multiple indices of stream condition so that results from different assemblages can be used together to produce more complete and rigorous assessments than provided by any single index alone. So where multiple assemblages are all in agreement about condition, our inference of human-caused alteration to the system or lack of alteration is strengthened by multiple lines of evidence. Where multiple assemblages are in disagreement, it may be possible to take advantage of the different sensitivities of those different groups to elucidate the effects of different types of stressors. The indices I used in these analyses were the California Stream Condition Index, which I already described, the H20 Algae Index, which is a hybrid index based on diatoms and soft algae together, and CRAM, the California Rapid Assessment Method, which is an index not based on a particular taxonomic assemblage, but that combines in-stream and riparian measures to indicate the overall condition of habitat and the riparian zone. The first step was to compare performance characteristics of H20 and CRAM with CSCI. In particular, I compared their bias, precision, sensitivity, and responsiveness. Again, in the interest of time, I'm not going to present detailed results of these performance evaluations. It's pretty easy to get bogged down in it. But I wanted you guys to know that that was the first step, and the goal was to evaluate whether cases of disagreement among indices might indicate moderate levels of stress to which some indices have responded but not others, or whether those disagreements might just be noise because one or more indices performs poorly. And the reason this was important was because the H20 index, the algae index, was developed for use in southern coastal California, but here I was applying it statewide, so it was important to evaluate its performance statewide. And CRAM was developed for statewide use, but its performance evaluations were not completely parallel with what we did for the CSCI. So I wanted to the extent possible, I wanted to have parallel evaluations of performance for all three indices. And in the end, I decided that H20 and CRAM performed well enough on a statewide scale that I was comfortable that the patterns of disagreement and of agreement and disagreement among indices were actually real signal, that they didn't result just because, you know, one or more indices had performance issues. The second step was to compare the frequency with which the three indices agreed and disagreed about site condition, and I wanted to identify whether cases of agreement and disagreement occurred in predictable ways according to which stressors affected a site. The data set I used was 628 probabilistic sites sampled between 2008 and 2012 for all three indices. Even though these are probability sites, some of them passed our reference screens, so they qualified as reference sites. I used the same criteria as for CSCI to establish condition categories for H20 and CRAM, that is the 30th, 10th, and 1st percentiles of reference sites. What I found was the three indices had full agreement at a little more than half, 55% of sites. So at 159, go back. At 159 of those 628 sites, all three indices agreed that biological condition was degraded. Those sites tended to be urban sites with high levels of activity in the upstream watershed. 185 of those 628 sites, all three indices agreed that condition was not degraded. Those sites tended to be either forested or to have mixed land cover in the upstream watershed. Many of them were reference, and a lot of them were moderate activity in terms of human activity in the upstream watershed. At the 284 sites that showed some type of disagreement, it was really a mixed bag of upstream land cover, and most of them had either moderate or high activity in the upstream watershed. A chi-square goodness of fit test, which assumed that there would be roughly equal numbers of sites in those three categories if patterns of agreement and disagreement were random, was highly significant, which means that those patterns of agreement and disagreement were highly non-random. So if we focus on just the 284 sites that had some form of disagreement, and remember in the overview when I described relative risk as being the increased risk of biological impairment when those stressor thresholds are exceeded, I use those same exceedance thresholds in these analyses. Sites where CSCI or bugs indicated degradation, but where H20 or algae indicated fair or good condition, and ignoring CRAM, exceedance of physical habitat or PHAB thresholds was far more likely than exceedance of chemical thresholds. So at the 69 sites where CSCI said condition was degraded, but H20 didn't, only 5 of those sites had chemistry-only exceedances, but 30 of them had PHAB-only exceedances. By contrast, at the 93 sites where H20 said condition was degraded, but where CSCI didn't, and again ignoring CRAM, 30 of those sites had only chemistry exceedances, but only 14 of them had only PHAB exceedances. So from these categorical results, it seems that CSCI or bugs are more sensitive to physical habitat disturbance, whereas H20 or algae is more sensitive to chemical disturbance. And then when CRAM was degraded and ignoring CSCI and H20, it was way more frequent to have only physical habitat exceedance. And that makes sense because CRAM is pretty much a physical habitat indicator. As a follow-up to that result, I regressed CSCI, CRAM, and H20 scores against a principal component analysis based on, in the top plots, that was based on 8 different chemistry variables and against 4 different physical habitat variables. And that first principal component axis is a synthetic or composite axis that describes the covariance between the original or raw variables. And what I found was that H20, the plot on the top right, had a much tighter response to that composite chemistry axis than did CSCI or CRAM. By contrast, CSCI and CRAM had a tighter response to the composite physical habitat axis compared to H20. So this supported those categorical results that CSCI and CRAM are more responsive to physical habitat disturbance and H20 is more responsive to chemical disturbance. This map just summarizes some regional patterns of agreement and disagreement. The green dots are sites where all 3 indicators agreed that no impairment had occurred. The red dots are sites where all 3 indicators agreed that impairment had occurred. And then the yellow dots are sites where there was some kind of disagreement. And the bar chart inset follows that same color coding pattern, and the y-axis is % of sites. And the main thing I want to point out is that in the North Coast and in the Sierra Nevada, there were no sites where all 3 indicators agreed that biological impairment had occurred. The flip side of that is the Central Valley, where there were very few sites that where all 3 indicators agreed that there was no impairment. The other regions, the Chaparral, Desert Modoc, and the South Coast, were somewhere in between those 2 extremes. So in conclusion, CRAM and H20 performed reasonably well on a statewide scale, despite the fact that they were unmodeled indices. I didn't talk much about the modeling aspect, but remember from the overview, I described how the CSCI was a predictive index. We used modeling to predict expected conditions. That wasn't the case for CRAM and algae, but nonetheless, they performed reasonably well on a statewide scale. Disagreement between indices was more likely to indicate moderate levels of stress to which some indices have responded, but not others, rather than noise due to poor performance in one or more indices. Patterns of agreement and disagreement were highly non-random. The indices frequently agreed that reference sites were unimpaired and that high activity sites were impaired. CRAM and CSCI were more sensitive to physical habitat stressors, whereas H20 was more sensitive to chemical stressors. And I think those results support that initial hypothesis, goal, hope, that where multiple assemblages are all in agreement, our inferences of human-caused alteration or lack of alteration are strengthened. And where they are in disagreement, the different sensitivities of the indices different kinds of stressors can potentially help us diagnose different causes of degradation. And that's all I have. Thank you very much for the opportunity to present.